Now we will discuss the equation of the wave. Basically, the equation of the wave will be the displacement of the particle of the wave. Basically, equation of the wave will be the displacement of the particles in the wave. So, equation of the wave will be the displacement of the particle in the wave. So, basically, suppose this is a wave and this is x-axis and this is y-axis. So basically, now you can see here, suppose I am taking this wave is traveling in some medium. This wave is traveling in some medium. Suppose this wave is traveling in the medium air. Okay, in air medium, this wave is traveling. So here there will be the particle in the medium. Okay, suppose this is the particle. Now focus on this particle. So for this particle, the displacement at this particular time of this particle will be this particle will be here. So means this particle at this time will be here. Basically, this particle is oscillating. This particle is oscillating like this. Okay, going up and down, up and down. This particle is going up and down. Suppose here is any particle. This particle at the same time, the displacement of the particle will be this. Okay, this will be the displacement of the another particle. So basically, with time this particle is oscillating. With time this particle is oscillating, means the displacement of the particle is changing with time. Displacement of the particle is changing with time. Now you can see this is the particle P1, this is a particle P2. When you are moving in this direction along the direction of the propagation, x is the direction of the propagation here in this wave. So when you will move in this direction, you will see this particle have this much displacement, this particle have this much displacement, this particle have this much displacement. Means with x also the displacement of different particle is changing. So you can say the displacement of the particle is changing with x also. So you can say displacement of the particle is a function of displacement of also. Displacement of the particle is function of x also. So this thing is clear. Y is equal to fx means y is the displacement of the particle. What is y? Y is representing displacement of particle. So displacement of the particle is a function of x, displacement of a particle is a function of time also, because the particle is oscillating about the mean position, means the displacement of the particle is changing with time, and with different location, at different location the particle will have different displacement. Okay, suppose this is the you can take the single particle also. This is a particle here. Here the displacement of the particle is this. Now this particle will be suppose here the displacement of the particle will be different. Okay, so this particle you can say is oscillating about the mean position. This particle is oscillating about the mean position.
Yes, sir.
And with distance or with x, the displacement of the particle is changing also. Okay, just try to imagine what is happening here. Okay, so if the particle will be here, suppose this will be the particle in the wave, so this will be the displacement of the particle. If this particle will after some time will be here, so this will be the displacement of the particle. Okay. And
Okay, sir.
if the particle will be here, suppose the particle will be here. So here this will be the displacement of the particle. So means with distance, the displacement of the particle is changing. So that is why the displacement of the particle is a function of time. But this particle is also oscillating about its mean position. Means the displacement of the particle is also changing with time. Okay, the displacement of the particle. Basically, I want to tell you the displacement of a particle is a function of x as well as time. Okay, and this wave is in the form of the sine, sine curve. Okay, so that is why this wave is known as the sinusoidal wave. And equation of the wave you can write like this: y is equal to a sine kx plus minus omega d. This can be the equation of the wave. This type, for this type of wave, this can be the equation of the wave, or this can be the equation of the wave omega t. Okay, this is, both are same things. Okay, here kx plus minus omega d, here omega d plus minus kx. So in any form you can get the equation. Okay. Why, and what is a here? A will be the maximum displacement of the particle. Okay, so what is a here?
Maximum displacement of the particle.
Maximum displacement of the particle. So where will be the maximum displacement of the particle? So you can say the maximum displacement of the particle, I will show here, will be like this. Okay, so this will be the maximum displacement of the particle. This will be a. Okay, so equation of the wave. Now if equation is written like this, y is equal to a sine omega, already told you, k, wave number already told you. If the wave is written like this, y is equal to a sine omega t plus kx. Okay, so with time, remember, with time there will be omega. With k, okay, with k there can be x, there can be z also. Okay, and or you can say with x there will be k. So this you have to remember. And if in between there is a plus sign, in this plus sign will tell you the negative or positive, and this x will tell you the direction of the propagation of the wave. So here is plus and this is x. So basically this wave is traveling in negative x direction. Now here is minus, here is minus, so, and here is x, so this wave is traveling along positive x direction. And why I have told you displacement of the particle, a is the amplitude. Now equation of the electromagnetic wave. Okay, first take the screenshot of this. Have you taken, have you completed this in the last class?
Yeah, sir.
So now please take the screenshot of this, and what you have to do now, please take the screenshot as well as, because after this we will start the optics. In optics there will be n number of the ray diagrams and all that, and when you will try to note down those diagram, it will take a lot of time. Half of the time I will teach you, half of the time will be taken for the noting down. So it is better
Okay,
to
sir.
take the, it is better to take the screenshot, and after that you can, if you want to do the practice, then you can see there the concept will, concept I will explain. Okay. Okay,
Okay,
so
sir.
take the screenshot and please arrange the
I'm
screenshot
done,
in
sir.
a proper manner. Okay, so this is the brief introduction of the wave. Take the screenshot.
Yes, sir. Done. Yes, sir. Done.
Done. Okay.
Yes, sir.
Okay. Okay, now
Yes, sir.
Okay. Now we have the electromagnetic wave. We have the electromagnetic wave. So now you should see what is the electromagnetic wave. Basically, this is the graphical representation of the electromagnetic wave. This is the graphic electromagnetic wave. What happens in an electromagnetic wave? In an electromagnetic wave, there is an oscillating electric field and there is an oscillating magnetic field. And the oscillation of electric field and magnetic field are perpendicular to each other as well as perpendicular to the direction of the propagation. Basically, this is the direction of the propagation. This is the propagation direction. Now you can see here, see here, electric field, we are considering electric field is oscillating along y direction, magnetic field is oscillating along z direction, and the wave is traveling along I cap means x direction. Okay. What is the meaning of oscillation? Oscillation means, first, oscillation means, see, what is the oscillation? Suppose this is the mean position, this is any position, and here is this particle. So this particle is going first up, then it is coming down, and then it is going downward in negative direction, then it is going upward, and then again this is known as the oscillation. Means something is increasing, decreasing, becomes zero, changing the direction is known as the oscillation.
Yes, sir.
So basically now you can see for the electric field, we have here assume that the electric field is oscillating along the y direction. Now you can see at this point what is the value of the electric field? 0. Now here there is some value of the electric field. Here this arrow, this arrow is representing the value of the electric field. So
Yes, sir.
from here to here the electric field is increasing or not?
Increasing, sir.
Yeah, electric field is increasing. So okay, so basically this will be the maximum value of the electric field, E naught. E naught will be the maximum value of the. So here the from here to here the electric field increases, and in positive direction, upward arrow is representing the positive y direction and downward arrow is representing the negative y direction. Okay, so from here to here the electric field is increasing, means the electric field is like this, electric field vector is like this. Now from here to here what is happening to the electric field? Decreasing. Okay, now first the
Yes.
electric field is increased like this, then the electric field is decreasing like this, and finally the electric field becomes zero, like this and like this. And after that what is happening? See the graph of red color graph, electric field here, again the electric field is becoming maximum. You can see here basically. Okay, so here the electric field then becoming maximum, this is the E naught. Again here the electric field is maximum, but from here to here the electric field is becoming maximum in negative direction, in uh, negative y direction. See the direction of the arrow. Okay, and again the electric field from here to here the electric field is increasing in negative direction, again the electric field is decreasing. Okay,
Okay.
and finally the electric field becomes zero. So you can say that electric field oscillate in y direction and you can say magnetic field oscillate in which direction? Z direction. In the same way, I have told you for the electric field, same way the magnetic field. Here the magnetic field is zero, then it is increasing, becomes maximum, then it is decreasing. Okay, then zero. Same is the case for the magnetic field. So basically, in an electromagnetic wave, there is an oscillation of electric field and magnetic field. These these oscillation of electric field and magnetic field are perpendicular to each other and also perpendicular to the direction of the direction of the propagation. Okay, so here you can write propagation of wave is along x direction. So propagation of the wave is along x direction. So basically this electromagnetic wave is transverse in nature. What is the meaning of the transverse? The electric field and the magnetic field are perpendicular to each other as well as the perpendicular to the direction of propagation. This is known as the transverse nature of the electromagnetic wave. Transverse nature of the electromagnetic wave. Okay.
Okay, sir.
So E naught is the peak value of the electric field I will represent. So basically this is the electric field oscillation and this is the magnetic field oscillation. The oscillation of electric field and magnetic field are perpendicular. So you can write here electric field and magnetic field oscillates perpendicular to each other perpendicular to each other as well as to the direction of propagation. Direction of propagation. This shows that electromagnetic wave is transverse in nature. Transverse in nature. Hello Naval.
Hello, sir.
Hello. So we are discussing the graphical representation of the electromagnetic wave and the transverse nature of the electromagnetic wave. So basically, this is the graphical representation of electromagnetic wave. So basically, this red color graph is showing the electric field variations or electric field oscillation, and this blue color graph is showing the magnetic field oscillation, and both these oscillations are perpendicular to each other. Okay, these are perpendicular to each other, and also these are perpendicular to the direction of the propagation also. So basically in electromagnetic wave, what are the field? First is the electric field oscillation, another is the magnetic field oscillation. So when you will write the equation of the electromagnetic wave now, so you have to write the equation of electric field and the equation of magnetic field. Simple. So basically this direction is x, I am supposing this is a y, z. So we have discussed electric field is along y, magnetic field is along z. Now equation of the electric field is given by E is equal to E naught sine kx minus omega t. This is the equation. So you can compare these from this equation. Why? What is the y? Y is the displacement. A is the maximum value of the particle displacement sine omega t, or here can be plus minus kx or kx minus omega t. The equation can be in this form or in this form. So focus on one type of equation. So y is equal to a sine kx plus minus omega t. So when you will write the equation of the electric field, so basically here you will write the value of the electric field, okay, and here is the maximum value of the electric field sine kx minus omega t you can write, and this is j cap. Here I have written minus because this wave is propagating in a positive x direction, okay, that is why you can write plus also. Now from this graph you can see that the electric field oscillations are there shown. I have shown here the electric field oscillation. This is time 0 and this is time t, showing the electric field oscillation, and electric field is oscillating along j cap, means along y axis, and direction of the propagation of the wave is along x axis. Now you can change this equation little bit. So this is ey now, this is ey. Basically this is the equation of the electric field we are writing. So this is E naught sine, k is the wave number. So k I have told you here, wave number k. Wave number k can be written as 2 pi by lambda. So we can write it as 2 pi by lambda. 2 pi by lambda. Minus omega can be written as 2 pi by t.
Yes, sir.
And this is t here. This is t here. This is j cap. So j cap means the electric field is along j cap. Now you can take 2 pi common. This is E naught. E naught, this is sine. And you can take 2 pi common. So you can write here 1 by lambda minus 1 by, this is t by t basically, t by t. And this is j cap. Further you can modify this equation. This is Ey is equal to E naught sine, this is 2 pi, and this is 1 by lambda. Now 1 upon time period can be written as frequency. So you can write frequency into t. So in different forms, either in this form you will get the equation of the electric field of electromagnetic wave, either in this form, either in this form, depending upon. But remember with t there will be omega. Remember with t the coefficient of t will be omega, okay, and the coefficient here will be x also. Actually I have not written x here, so here will be x also, x by lambda. So the coefficient of x will be k, okay. So with t there will be omega, and with x there will be k. So here will be x. So this is the equation of the electric field in electromagnetic wave. Now same you can write for the magnetic field. V is equal to V naught sine kx minus omega t into k cap. This minus sign is representing this wave is going in positive x direction. This x will decide the direction, and okay, this negative sign will decide the negative direction or positive direction. Okay, V naught is the maximum value. So magnetic field is also oscillating, but this time the magnetic field is oscillating along the z axis we have discussed. Okay, Nawal. So you should take the screenshot from here because I have started from here.
Okay.
Done?
Yes, sir.
Yes, sir.
Okay, so just there is a requirement of this also because without this there will be problem. So take the screenshot of this, Nawal.
Done, sir.
Done? Okay. Okay. So we have just completed.
Yeah, sir.
Yes, sir.
Okay. Take the screenshot of this also, Nawal. Matthew, you have already completed.
Yes, sir. I've already taken a screenshot.
Okay. Okay. No problem. Basically, this is the basic idea how can we write the equation of the wave. Otherwise, you will have problem when directly I will write the equation of the electric field or the electromagnetic wave. Nawal completed this. Okay. So take the screenshot of this also.
Done, sir.
Okay. Okay. Now Matthew and Nawal both you can just take the screenshot from here also. This is the equation of the electric field in the electromagnetic wave. And electric field is oscillating along y direction.
Done.
Okay. Similarly, you can write the like you have written for the electric field, no? You can write for the magnetic field also, but there is no requirement, so I am not just saying. Okay, just take the screenshot of this also. Done, Matthew?
Yes, sir.
Okay, so this we have completed. Okay, so here graphical representation of the electromagnetic wave. So take the screenshot of this also. Just a minute, I am just zooming it like this. So now you can take. Completed, Matthew and Nawal?
Oh, yes, sir.
Okay. So now see what is there in electromagnetic wave, electric field and magnetic field. What is there? In electromagnetic wave, electric field and magnetic field. So electric field is there and electric field is changing with time and magnetic field is also changing with time. Changing with time means oscillating. So if I want to write the peak value of the electric field, at some time there will be the maximum value also of electric field. So this is the maximum value of the electric field. Somewhere there will be the maximum value of the magnetic field also. Okay, so there is a relation between the maximum value of the electric field and the magnetic field. Very simple relation. And now I want to tell you light is an electromagnetic wave. Light is an electromagnetic wave. So if I am saying that speed of light in air, vacuum or free space means speed of light, speed of electromagnetic wave in in air, vacuum or space, okay, that will be 3 into 10 to the power 8 meter per second. Okay, so there is a relation between the peak value of the electric field or the peak value of the magnetic field. So this is the relation, simple relation: peak value or maximum value of the electric field in electromagnetic wave, peak value or maximum value of the magnetic value of the magnetic field in electromagnetic wave. This is given by E naught by V naught is equal to C. What is C? C is the speed of electromagnetic wave. C is the speed of electromagnetic wave. Speed of, you can say, light or electromagnetic wave in free space, air or vacuum. Free space, air or vacuum. And C is equal to 3 into 10 to the power 8 meter per second. So this relation is very important. You have to remember. After this, now if you are there is for the medium, there are other properties also, like you have heard relative permittivity, or you can say absolute permittivity and permeability. Permittivity means epsilon and permittivity means epsilon and permeability means mu. Okay, we have now in Coulomb's law 1 upon 4 pi epsilon naught. So what is epsilon naught? And we have mu naught by 4 pi. So this thing and this thing, basically this is the permittivity of free space, this is the permeability of free space. And for medium, we can write this is the permittivity of the medium, and mu m, we can write the permeability of medium. So there is a relation between the speed of the light and the permittivity and permeability of the medium or free space. Very simple relation. Permittivity and permeability and permittivity of medium. In air, if you are talking, in air, vacuum or free space, you are talking that speed of light or speed of electromagnetic wave is equal to 1 upon mu naught into epsilon naught. C is the speed of light in free space, mu naught is the permeability of free space, epsilon naught is the permittivity of the free space. Now there is a relation between the permittivity of medium and permittivity of free space. Okay, that is defined by the relative permittivity. Now relative permeability is represented by mu r, and relative permeability is equal to the permeability in any medium divided by the permeability in air. Okay, mu m is representing the permeability of medium. In the same way, there is a relation between the relative permittivity. So relative permittivity is represented by epsilon r or k. This relative permittivity is also known as the dielectric constant. This is also known as the dielectric constant. Dielectric constant of the medium. So relative permittivity or dielectric constant is relative permittivity in medium divided by the relative permittivity is equal to permittivity of any medium divided by permittivity of air or free space. This is the relation. Now, speed of electromagnetic wave, basically this is the speed of light in free space, you can say, or you can say speed of electromagnetic wave also. speed of electromagnetic wave in free space also, you can say. Now in any other medium other than the air, vacuum, because light is an electromagnetic wave and light can travel in other mediums also, like in water also light travels, okay, in glass also light can travel, but in air the speed of light will be different. In water the speed of light will be different. In glass the speed of light will be different. Okay, so what is light? Light is an electromagnetic wave. So we are discussing the speed of electromagnetic wave in other medium. So in other medium the speed of the electromagnetic wave is given by 1 divided by permeability of that medium, multiplied by permittivity of that medium. For example, if I am saying light is traveling in water, electromagnetic wave or light is traveling in water, then speed of electromagnetic wave in water is equal to 1 upon permeability of water multiplied by permittivity of water. Okay. After this, we will have one question. This question, okay, first we will solve. Okay, so first take the screenshot of this, then we will move. Okay, first complete this. You can take the screenshots. Completed, Matthew and Nabal? Taken the screenshots?
Yes.
Yes, sir.
Okay. Okay, now just a minute. Now you can take the screenshot, both of you. And after the class, arrange the screenshots. Okay. Okay, so take the screenshot again. You can ask me to scroll up also if you have not taken the screenshot.
Taken, sir.
Taken? Okay, now take this. Okay, so so first we will solve this question. In this question, it is given that, just a minute. First, read the question by yourself. Matthew, can you tell me in which direction this wave is going? This is the equation of basically electric field is given. So can you tell me what in which direction the electromagnetic wave is going? Hmm?
Is towards the electric field. No.
No. See here, here is the positive sign now.
Yeah,
I have
sir. So
I
it'll
have
be
told
towards the positive, like was it the right side of the graph?
no. Actually,
Then
just a minute. You have to understand this. I have told you if in between there is plus sign means the wave is going in negative. And if here is x, then negative x. If here is negative sign means the wave is going towards positive, and here is x means positive x. So in this question, this is they are asking what is the direction of the propagation. Answer first. Answer A. See, this is a positive sign. Okay, this sign is the positive, and this is x. This is x here. You have to see the coefficient. Okay, and here is 10 to the power 11. Basically, this is 10 to the power 11. Okay, what is the equation of the electric field? E is equal to E naught sine omega t minus kx, and I have told you this equation can also be written in this form. E is equal to E naught sine kx minus or plus minus omega t. In this form also can be written this equation. Okay, so different ways to write the equation. So basically this equation is written, here is plus sign in between, so kx plus omega t. So here with x this value will be k, and with t this value will be omega. Remember this point. Now first answer is the wave is propagating towards negative x. Okay, second answer, they are asking the speed of the wave. Speed of the wave is given by omega divided by k. So omega, Matthew, what is omega?
wavelength.
No. Here, what is the value of the omega in this question?
Oh, okay. 1.5 into 10 raised to 1. No, 10
Yeah,
raised to 1.
10 to the power 11. And
Yeah, 11, yeah.
k is 0.5 into 10 to the power 3. So basically, when you will cancel this, you will get 3 into 10 to the power 8. Basically, 3 is into 10 to the power 8 meter per second is the speed of light or speed of electromagnetic wave in vacuum. So this is the first question. Now another question. This question is little bit tricky. Okay, this question is little bit tricky. So a plane electromagnetic wave, this is the equation of the electric field of that electromagnetic wave, propagates in a non-magnetic medium. The meaning of the non-magnetic medium means that for that medium the value of the permeability is equal to mu naught of dielectric constant K. So they have asked the value of the dielectric constant. Now Matthew, can you tell me in which direction this wave is going?
So that's U, right? Or
This is 4.
okay, S4.
Basically with T you have omega, with X you have K. So first calculate the speed of this wave in this medium. Omega by K. Omega is 6 into 10 to the power 8 divided by 4. So basically it will become 3 into 10 to the power 8 divided by 2. Okay, 3 into 10 to the power 8 divided by 2. And 3 into 10 to the power 8 is C divided by 2. So basically speed of this wave is equal to C by 2. This is your equation number 1. Okay.
Okay, sir.
Now they are asking the dielectric constant. So dielectric constant is given by epsilon m divided by epsilon naught. Okay, epsilon n divided by epsilon naught. So from here you can calculate epsilon m, that is K times of epsilon naught. This is your equation number 2. Now speed of the electromagnetic wave have another formula, that is given by mu m into epsilon m. This is equal to 1 upon. So mu m here is given as mu naught. Mu m is equal to mu naught. So here you will put mu naught, and epsilon m is K times of epsilon naught. So you can write this as epsilon naught into K. Now C is equal to 1 upon under root mu naught into epsilon naught. Now 1 upon mu naught into epsilon naught is C. So basically you have V is equal to C divided by under root of K. Now this is the speed of the wave that you have calculated C by 2. This is C by under root K. C and C will be cancelled out. You will get under root K divide is equal to 2. So what is the value of the K? You will get 4. Okay, so take the screenshot.
Done, sir.
Then so take the screenshot of this also.
Done, sir.
Done. Okay, take this also.
Not so.
Done. Okay. So after this, we will discuss the energy of the electromagnetic wave. Energy of the electromagnetic wave. Basically, in electromagnetic wave, okay, in electromagnetic wave, uh, electric field is there and magnetic field is there. There is a oscillation of electric field and magnetic field, and those are oscillating perpendicular to each other. So what type of energy the electromagnetic wave will have? Electrical energy as well as the magnetic energy. Okay. So here na, and we will discuss the energy density. Energy density means the amount of energy contained in a unit volume. Okay. In a unit volume, how much is the energy? Is the energy density. Energy per unit volume is the energy density. So basically, energy density of electromagnetic wave. So electromagnetic wave carry energy as they travel through space. Thus, energy is contained in oscillating electrical magnetic field. Equal amount of energy is contributed by the electric and the magnetic field. So this thing I will prove later. Equal amount of energy is contributed by the electric field and the magnetic field in electromagnetic wave. So we know that the electromagnetic wave can be produced by the oscillating charge, and from where we get the oscillating charge? From the LC oscillation or LC circuit. Okay. Okay, now we will discuss energy density for the electric field. Energy density for the electric field. Energy density of the electric field. Suppose this is the capacitor, parallel plate capacitor, and this capacitor plate have the area A. Capacitor, na? No, you know capacitor, Matthew. Nawal, do you know what is capacitor?
Yes, sir.
Okay, then it's good. So basically, this is the capacitor, parallel plate capacitor, and this capacitor is in the charging condition. Basically, this capacitor is charging. So if this capacitor is charging, means the charge on the capacitor is increasing. If the charge on the capacitor is increasing, means on this plate negative charge is increasing, on this plate the positive charge is increasing. So due to the charge, there will be the electric field. Electric field will be from positive charge to the negative charge, like this. This will be the electric field, and this electric field here you are getting this electric field. This electric field is changing with time. This electric field is changing with time. Why this electric field is changing with time? Because on the plates of the capacitor, the charge is increasing, and due to increase in charge, the electric field is increasing. So A is the area of the plate of the capacitor, D is the distance between the capacitor plate. Earlier also I have told you this thing, I know. One more thing I have told you in the chapter capacitor. Energy density for the capacitor, or you can say energy density for the electric field. Energy density for the basically in between the plates of capacitor there is electric field. So in the electric field, how much will be the energy in unit volume is known as the energy density. So basically, energy density of electric field I will represent a small u with e, a small u suffix e. Okay, and this energy density for the electric field is given by half. I am not driving this. Okay, if you want to see the derivation, You can check your notes of that capacitor. There you will get this derivation. I have done this derivation. Half epsilon naught into E naught square. Epsilon naught, just I have told you, absolute permittivity of the space in free space, you can say. E is the electric field. Okay. Okay. Now I have told you this electric field is changing with time. Electric field is variable. Here this electric field is not constant. Why this electric field is not constant? Because charge on the plates of the capacitor. If you want to write the electric field in between the plates of the capacitor, this will be given by sigma by epsilon naught. Sigma is the surface charge density, and sigma is charge divided by area into epsilon naught, and this charge is changing. So now you can relate this charge is changing, so electric field is changing. And equation of that electric field is E is equal to E naught sine kx minus omega t. Hello Matthew, what happened?
Sorry, sir. There was some internet issues. So I had to.
Okay. So we are discussing the energy density of the electric field. Okay, so basically this is the parallel plate capacitor. So this capacitor is in the charging condition. So if this capacitor is in the charging condition, so charge on the plates of the capacitor will increase, and due to that charge there will be the electric field in between the plates of the capacitor. So electric field is always from positive to the negative charge. So this will be the electric field lines, or you can say the electric field, and this electric field will be variable. Why? Because the charge on the plates of the capacitor is changing. For the electric field between the plates of the capacitor, given by sigma by epsilon naught. Sigma is the surface charge density. Okay, surface charge density means charge per unit area. This charge is changing, so you can say electric field is also changing. And the equation of this electric field is given by E is equal to E naught sine kx minus omega t. Matthew, clear?
Yes, sir.
Now what we will do now, we will just, because this is the energy density, we are calculating the energy density of the electric field. We are calculating, okay. We have half of epsilon naught into E naught square. So this is E naught square, and this electric field value is this. So we will put this value here in this equation. So we will get E naught square sine square kx minus omega t. Now this is variable. This is variable. Why? Because this electric field is variable. See, here is time. Here is x. This time is changing. Time is changing. So if time is changing, so you can say the electric field, this value of the sign is changing again and again. So means you can say the electrical energy density is changing, or energy density for the electric field is variable. So this quantity is variable. Now what we will do? Earlier I have told you that if the equation of the EMF we have written, or you can say the equation of the EMF you can take. In alternating current, we have discussed equation of the EMF is E is equal to E naught sine omega t. There, I have told you this E there was changing with time. So in that case, what we have done, we have just calculated the average value. We have just calculated the average value of the EMF there, and we got 2 E naught divided by pi. So if something is changing with time, so basically we calculate the average value. So for this also we will calculate the average value. Now average value of E is this, and bar of half epsilon naught E naught square sine square kx minus omega t. This is the bar. I have done the derivation of power also with this method. Now you can write this is the average value of the electric field. Now this half is constant, epsilon naught is constant, E naught square is also constant. Now average value of sine square kx minus omega t. Can anyone tell me what will be the average value of this for a full cycle? Sine square kx minus omega t. Matthew? I have told you that.
New.
No. It will be half. I have told you that the average value of sine square is always half.
Also, you also value of sine. Oh, okay.
If I am saying the average value of sine, that is equal to 0. If I am saying the average value of cos, that is equal to 0. If I am saying average value of cos square, that is equal to half. Now average value of sine square is half, so you will get this value, half of epsilon naught into E naught square into half. So finally the energy density of electric field will be 1/4 epsilon naught into E naught square. In the same way, you can calculate the energy density of the magnetic field. Energy density of the magnetic field is given by half of mu naught into B square, energy density of the magnetic field. So you will put the equation of the magnetic field there, and that magnetic field will be changing with time. So you will calculate by taking the average. So this is the energy density of the electric field. You can similarly calculate the energy density of the magnetic field. So earlier you have taken the capacitor, because in capacitor there is a energy, there is an electric field. In case of solenoid, there is a magnetic field. So here is the magnetic field in between or inside the solenoid, and I think in the last chapter, energy density for the inductor, or you can say energy density of the magnetic field, we have just calculated this, half mu naught into B square. What is B? B is the magnetic field inside the solenoid. Just wait. No, it's fine. Remember, energy density of the magnetic field. This is the energy density of the magnetic field. half into mu naught, half into mu naught into B square. What is B? Magnetic field inside the solenoid. Energy density for magnetic field. And we know that this current is alternating current. If I is changing, if I am saying the current I is changing continuously, basically this current is AC current. So this current will changing continuously, and what is the magnetic field due to the solenoid? Mu naught N and I. This I is changing, so this magnetic field is changing. If this magnetic field is changing, and the equation of that magnetic field is this. So when you will put this value here, you will get this is also variable, and again you will calculate the average, and you will get this value 1 by 4 mu naught into V naught square, average value of energy density of magnetic field. Okay. So now we will calculate the total energy density of electromagnetic wave. In electromagnetic wave, there is one electric field and there is another magnetic field. There is electric field as well as magnetic field. So for the total energy density of electromagnetic wave, what we have to do? Total energy density of the electromagnetic wave, small u, is equal to the energy density in electromagnetic wave, that is energy density of the electric field plus energy density of the magnetic field. In an electromagnetic wave, there is electric field and magnetic field. That is why for the total energy density of the electromagnetic wave, so we will take here average values. Okay. We know all the values. Okay. We know all the values. So suppose here you can write this is u. And there is one more thing that I want to clear. We will check whether this UE average is equal to UB average. Okay. So I am starting with UE average. What is UE average? This is a note point, you can say. Half of 1 by 4 of, we have just derived, this is 1 by 4 of epsilon naught into E naught square. Now there is a relation between E naught and B naught. See, so from here, this E naught can be written as C times of B naught. If you will write E naught square, it will become C square into B naught square. So this is equal to 1 by 4 of epsilon naught. E naught square can be written as B naught square into C square. Now there is another relation. C is equal to 1 upon under root of mu naught into epsilon naught, and C square can be written as 1 upon mu naught into epsilon naught. So it can be written as 1 by 4 of epsilon naught B naught square. C square can be written as 1 upon mu naught into epsilon naught. Epsilon naught and epsilon naught can be cancelled out. So finally, what you will get? 1 by 4 of mu naught, 1 by 4 of mu naught into B naught square. And what is this value? Basically, this value is the UV average, energy density for the magnet. So basically, from here it is clear that energy density, average energy density for the electric field is equal to the average energy density of magnetic field in electromagnetic wave. This is clear. Okay. So now we can calculate the total energy density. I can write total energy density as 2 times of energy density of electric field, or I can write 2 times of energy density of magnetic field, because this, for the total you will do the average of electric plus magnetic, and you can write either this equal to this or this equal to this, so you will get 2 times of E or you will get 2 times of V. So you can write for the total energy 2 times of what is UE, average. Basically this is average value. Average value, so it will be 1 by 4 of epsilon naught into E naught square. So total energy density of the electromagnetic wave is 1 by 2 epsilon naught into E naught square. In terms of the electric field, this is the total energy of electromagnetic wave. So this can be written as 1 upon what is magnetic energy density, 1 by 4 of mu naught into V naught square. So this can be written as 1 by 2 of mu naught into V naught square. So this is the total energy density in terms of the peak value of magnetic field. Okay. So what is U? U is the total energy density of electromagnetic wave. Finally, you can write that total energy density of the electromagnetic wave is half of the electrical energy density of UE by 2, or you can write UV by 2. Okay. Basically, UE and UV here are representing the average values. Okay, so this question, see this question. In this question, they are saying a magnetic field Matthew and Nawal, are you there?
Yes, sir.
Yes, sir.
Okay. Now they are saying a magnetic field in a plane electromagnetic wave is given by, basically this is the magnetic field given in an electromagnetic wave. Find the average energy density corresponding to electric field. Very simple question. Find the energy density corresponding to electric field. Can you tell me what is the peak value of the magnetic field? Matthew, can you tell me what is the peak value of the magnetic field?
For 400 raised to minus 5.
No, 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 no. This is the equation of the magnetic field given. Okay. So what you will do, you will compare with this equation. V is equal to V naught sine omega t minus kx. Basically, when
So
you will,
omega t will be 4 into 10 raised to minus
yeah,
5.
yeah.
And
So
yeah.
what we will do now for completing this, there is no requirement. Just I am telling for. So basically, this is Bina, and you can write this as 200 micro Tesla. and this is sine, and this 400 can be multiplied to this bracket. So it will 4 can be multiplied to this bracket. So 4 into 10 to the power minus 5, and this is t, and it can be written as 4 into 10 to the power minus 5 x by c. So this can be written like this. Now, can you tell me in which direction this wave is going? See, here is the negative sign na, and this is x. So this negative sign means plus and x direction. In plus x direction is the direction of the propagation. Okay. By the way, what is this? This will be omega, and this will be
Yes.
k. And k will be 4 into 10 to the power minus 5. K in this will be the coefficient of x. 4 into 10 to the power minus 5 by c will be the k. But there is no requirement of all these things. Basically, I am just telling uh, for the interest. Basically, we want to find the electrical energy density. So what is the formula? Half of 1 by 4 of 1 by 4 of epsilon naught into E naught square. But we have the value of V naught, that is 200 micro Tesla. Okay, this is basically V naught, maximum value of the magnetic field. Now, how we will convert this? We know that E naught by V naught is equal to C. Okay, so from here we can convert this E naught. So this E naught can be written as C times of V naught. So it can be written as 1 by 4 of epsilon naught E naught square means C square into V naught square. Now from here you can calculate half of epsilon naught is what is the value of epsilon naught? (8.85 into 10 to the power minus 11). C square means 3 into 10 to the power 8 square. B naught square means 200 into 10 to the power minus 6 square. So when you will calculate this, you will get the answer. And in there is one another way to calculate this question. This value and this value are equal, and this is also given by half of 1 by 4 of mu naught into B naught square. So 1 upon 4 mu naught is given by 4 pi into 10 to the power minus 7, and B naught is given by 200 micro Tesla, 10 to the power minus 6 square. Same answer you will get here also. Okay, so take the screenshot, then we will wind up here.
I already for the before one, sir. Can you show the the last question we did?
Okay. Okay, Nawal, just take the screenshots. So here I have proved that na, the average value of the electric field is equal to the average value of the magnetic field. Nawal, taken the screenshots? Oh, no. Okay, so Matthew, you have done this.
Yes, sir. Just show the last question. The rest everything I've taken already.
Okay.
Yes, sir. I'm done. Can
Scroll
you scroll
down.
down? Yeah.
Okay,
Yes, sir.
Matthew. So we will meet now in the next class.
Okay,
And
sir.
in the next class, what we will do, I am just telling,